Uh, Hello, dear students. Hope you are fine. I am Professor Dr. Shiraz Ahmed, talking you from Peshawar city of Pakistan. Uh, as per my introduction, I am a professor in computer sciences and acting as dean at my university in Ikra National University, Peshawar, Pakistan. Um, I will be teaching you time series analysis course in postgraduate classes to you people in this ongoing semester. Hopefully, we will have a good working relationship throughout this semester. I want to clarify some things for you people so that you are aware when we are studying this course. First of all, I will be trying to regularly take my class on Wednesdays, the same timing. This is your first class, and hopefully we'll be having the same classes throughout on Wednesdays. Secondly, I will be assigning you certain assignments and quizzes throughout this time period, and I will be happy if you people can submit your assignments and activities well in time before the next week starts. So that will be feasible for me as well to correctly mark your assignments, give you good grades, and I hope that by the end of this semester, all of you will be getting good grades. We will be discussing certain things on this online classes, and I will be posting 3 open class forum questions. And I request you to please, if you are unable to attend the classes, go through these recordings and submit the answers of these open class forum questions. Also, I will appreciate if you people can spare your time and actively participate in these classes so that I can answer your queries at the runtime. Otherwise, I will be happy to answer you any queries related to your course, either through the internal email of UTEL University or the open forum or the messenger of your UTEL University forum. So please don't hesitate to ask any questions anytime, and I will be happy to answer you those questions and queries so that you can clarify your concepts. Let's move on to the first lecture of the today, that is based on your introduction to the course. And likewise, also, I will post a case study as well on this time series analysis. You are grown-up people, mature enough, and studying in postgraduate levels. And I hope you will understand the concepts fully, grab them, and satisfy your concepts. Ask as many questions as you want. I'm also available here for you people. Anytime you can post or email send to me. And secondly, go through these recordings again and again. Submit your case study activities well in time, please. So now I would be sharing my screen so that we can come up with the first lecture of today. But first, before going on to the class, I want to ask an open forum question from you people. I'm typing in the chat box. So my first open class question is, what do you understand by the time series? Maybe this topic is new for you and you people have not gone through this subject before. So before starting, we should get a concept that what I mean by the time series. So whatever the thing comes in your mind, please do type in And by your own concept, I want to check whether you people are actually getting to the point or not. So now sharing the slides with you people. So these are some lecture slides on time series analysis. This will be the outline of the course. What is the practical information regarding the time series? Introductory examples, brief outline. So first of all, let's have an introductory example. You can see that this is a graph between two variables, your x-axis and your y-axis. And this graph is continuous graph and it is not broken somewhere. Now this graph shows that there is a variation. Sometimes it's up, sometimes it's down, sometimes very up, but it's continuous and it is varying with the time. So your x-axis is the time and your y-axis are giving me some values. These values can be money, these values can be some other thing, but actually this graph is actually known as a time series because it's a serial graph, not broken somewhere, nothing but continuous. Now, for example, another example, we see consumption of district heating. That is the heat consumption, and this is a graph for the air temperature. You can see, again, this is a graph which is continuous and going on like this. So this is actually the time series varying with the time. Now you can see November, December, January, February, and so on. Similarly, month-wise, again, this is an ongoing graph, which is a continuous graph, and these are the examples for the time series. Another example, we can see that in this, we have the air temperature versus the heat consumption. Now, these are the points. These are not the graph, but we can imaginarize that these points can be combined together to form a straight line. And this is an imaginary line which is formed with the help of joining of these points. Again, it is an assumption of a time series. Another example, model error. We can see different graphs, different errors, which we have seen. Again, its x-axis is on months and y-axis represents the model error. There are two types. See, one graph is like this and one graph is like this. This one is more clearer to you because the values are less, but in this case, as the values are more, the graph is more jumbled. So what is the brief outline of the course? General aspects of multivariate random variables, prediction using the general linear model, time series models, some theory on linear systems, time series models with external input. Some goals we want to achieve, characterization of time series or signals, correlation functions, covariance functions, spectral distributions, stationarity, ergodicity, linearity. Then we will have the signal processing, and in these things we will discuss about filtering, sampling, and smoothing, modeling with or without external point, and the last one will be prediction and control. Now, when we talk about multivariate random variables, random variables are those variables which can be assigned any values. They can be of various nature, therefore they are known as multivariate. So in these things, we will be expecting to discuss joint and marginal densities, conditional distributions, expectations and moments, moments of multivariate random variables, conditional expectation, the multivariate normal distribution, distributions derived from the normal distribution, and linear projections. From these wordings, you can be aware that mostly we will be talking about um, the statistical analysis. So before going on to the next slide, again, we can have an open forum question. That is my question number 2. What is the difference what is the difference between a normal variable and a random variable? So I want to inquire from you people that you would have used variables, you would have learned about variables. Now we are using a new term, and that is random variable. So what is the difference between the two? So this is my open question 2. Coming in detail regarding the multivariate random variables, by definition, we say that a random variable is in the form of random vector. It is an n-dimensional random variable represented in a vector form like this. So x1, x2 up to xn, they are in a vector form and they are represented by capital X. So actually x is now a random variable but represented in a random vector form. Similarly, if I want to have a joint distribution function, so capital F of small x1 up to xn, they can be a function of probability where capital X1 will be less than or equal to x1, capital X2 will be less than or equal to x2, and so on up to xn. Then we have the probability density function if in the case of continuous. There will be two cases, continuous case and discrete case. So one is the continuous one and the other is the discrete case. In the case of continuous, the PDF, which is called probability density function, that is the small f is a function of x1 to xn. So that is actually the partial derivative of with power n of the function capital F defined, where this capital F is actually the integral of these small functions in terms of the time. So when we take the integral, that will become the function. And if we integrate, if we derivate it partially with respect to their own variables, then we get the PDF. And in the case of the discrete function, the same thing is represented as the probability. No integration, no derivation involved in the discrete case, but it is involved in the case of continuous case. Then we have another term which is known as the joint PDF. So this is the formula to calculate the joint PDF, and it is also known as multivariate normal distribution. So f of x in terms of capital X, that is equal to 1 over 2 pi power n by 2 and under root of determinant of sigma exponent of this vector. This sigma must be positive semi-definite. In terms of notation, we can write as capital X is a function of mu and it is a function of mu and sigma. In standardized multivariate normal, this X is normally distributed. This is I, but it is actually represented 1. Then n of mu sigma is equal to mu plus t of normal distribution from 0 to 1. So t is a vector representation over here. If x, which is approaching to approximately equal to n u sigma and y is equal to a plus bx, then y is actually a summation of n a plus b mu and b sigma b transpose. More relation in this distribution we will study in next sections. Then we have the marginal density function. So subvector x1 up to xx to the transpose where k is less than n. So in the above definitions, we are studying till n, but now we are studying it up to k. So this is a subvector because k is less than equal to and this is known as marginal density function. So marginal density function is actually equal to f of s x1 to xk, and it is integration from minus infinity to plus infinity of individual terms, and each term will have its own differential. So these are actually the different types of graphical approaches which we used in the case of marginal distribution, marginal density functions. So these are different types of charts. They can be represented in this form, three-dimensional. It can be in histogram form, or it is in two-dimensional form. Now, in the next class, we will be studying about these conditional distributions. What are they actually representing, and what are their formula and applications? For now, I want to put another open class question. What is the difference between PDF and CDF? PDF, I have been discussing in this class probability density function. You can see in the recordings as well. And CDF stands for cumulative density function. Um, we have not yet discussed CDF, but I want you people to check on Google and give me the difference between these two, that what is PDF and what is CDF. So it will be good enough if you people can go through it, understand between the difference, so that when we come up in the next class, you should be able to be clear enough about CDF, because in the next lecture, we will be discussing about the CDF. Once again, please, I was telling you that try to answer your queries well in time, so that we should be able to give you good grades. And all I want, that all my students should pass this course with good grades. I know that this is a little mathematical, complex type of course, but I will be trying to answer your queries as much as possible. But I need that my students should clarify your concept. Hopefully to meet you soon in the next class. Till that time, please take very good care of yourselves. Thank you very much.